Pacific Ocean. Dawn, 1944. The sun breaks over the water in a thin line of gold. Waves roll gently toward the black silhouettes of Japanese soldiers crouched on a coral ridge. They've held this outpost for months, waiting for the next American strike. Through binoculars, one lookout steadies his breath. What he sees doesn't make sense. On the horizon, hundreds of strange shapes drift together. Metal boxes linking, forming platforms. Ships lower cranes, trucks roll onto floating bridges, and in hours, a harbor begins to appear where no land exists. The sea itself is turning into America's greatest weapon. Engines roar. Steel pontoons clang. Seabees, the U.S. Navy's construction battalions, hammer and weld beneath the tropical heat. Offshore, waves pound the new causeways, yet the structure holds, swaying, alive, unstoppable. The Japanese commander lowers his binoculars. A harbor built from nothing, assembled faster than their artillery can target. For the first time, he realizes, the Americans have learned how to move the land itself. The war that needed a new kind of harbor. By mid-1944, the Pacific had turned into a vast machine of movement. From the steaming jungles of New Guinea to the black sands of the Mariana Islands, every victory for the Allies brought the same impossible question: how do you land an army on an island with no port? The Pacific Ocean was not Europe. It was endless water and volcanic rock, a theater defined by distance. Each island was a fortress, isolated, ringed with coral, lacking deep-water docks. Japan's strategy exploited this geography perfectly. Its Imperial Navy had turned thousands of small islands into fixed points of defense, betting that America's supply chain could never reach far enough or fast enough to sustain invasion after invasion. But in Washington and Pearl Harbor, a different idea was forming. Admiral Chester Nimitz understood that wars are not won only by firepower, they are won by logistics. His fleet could smash any target, but without ports, fuel, and repair facilities, victory would die on the beaches. What America needed was not just ships, it needed mobility on a scale the world had never seen. Enter the Seabees, the naval construction battalions. Formed in 1942, these were builders who fought and fighters who built. Their motto, "We build, we fight," was not a slogan but a promise. Many were former carpenters, miners, welders, and engineers, drafted straight from civilian life. Armed with rifles and bulldozers, they followed the Marines into hell and created order from chaos. Early landings had already exposed the problem. At Tarawa, supplies sank in deep surf. Trucks bogged down in coral shallows. Wounded men waited hours for evacuation because no dock could be built under fire. Every ton of ammunition, fuel, and food had to be ferried ashore by hand. The cost was time and lives. By 1943, American engineers began to sketch something extraordinary: a modular floating dock system that could be carried across the ocean and assembled on any beach. Each section, a steel pontoon roughly the size of a small boat, could be linked with others like building blocks. Connect enough and you had a pier. Connect hundreds and you had a port. It was an audacious idea. The Navy Bureau of Yards and Docks collaborated with private engineers, experimenting on American coastlines with prototypes that rose and fell with the tides. They tested stability under wave pressure, corrosion, and artillery impact. What emerged was a design so simple and flexible that it could transform amphibious warfare forever: the pontoon causeway system. While the concept of temporary harbors had been explored by the British for Europe's D-Day, through the famous Mulberry harbors, the Pacific demanded something tougher, more mobile, and capable of surviving typhoons. America's version would have to travel thousands of miles, be unloaded at sea, and endure bombardment, all without the luxury of calm channel waters. By late 1943, convoys were leaving San Diego and Pearl Harbor carrying these strange flat-packed steel boxes. Each was marked, inventoried, and assigned to a construction battalion. The Seabees nicknamed them Magic Cubes. With them came cranes, winches, prefabricated ramps, and portable fuel lines. Together they formed what strategists would soon call a harbor in a kit. As the island-hopping campaign accelerated, Kwajalein, Saipan, Guam, Peleliu, the pontoon systems followed. Within hours of securing a beachhead, Seabees could create floating bridges reaching hundreds of meters into the surf. LSTs, landing ship tank, unloaded directly onto them, bypassing reefs that had destroyed earlier assaults. Bulldozers rumbled ashore, constructing airstrips while artillery still thundered nearby. The front line was no longer a place of waiting. It was a place of immediate construction. To the Japanese defenders watching from cliffs and pillboxes, the sight was incomprehensible. In their doctrine, the sea was an obstacle, a natural defense that slowed enemies until they could be annihilated. Now the sea itself was being tamed. American ships anchored miles out, offloaded supplies straight onto platforms that seemed to float over the waves like a bridge to nowhere, and yet everywhere. This technological leap changed the rhythm of war. Islands that were expected to resist for weeks fell in days. The ability to offload tanks and ammunition without a port gave commanders unprecedented speed. The Pacific, once Japan's shield, was becoming America's highway. And as the Marines planted new flags across the ocean, whispers began to reach Tokyo headquarters. Rumors of a floating harbor, a mechanical island, an enemy who could build land from the sea itself. It was only the beginning of a revolution in warfare logistics, one that would soon reach the next, even more ambitious phase. By 1944, America had turned war into an engineering problem, and then solved it. Every new island assault was a test site, every invasion a laboratory of logistics. Behind the Marines' rifles and the Navy's guns stood an invisible army of planners, welders, and engineers, tasked with one impossible mission: to bring a port where there was none. The key was modularity. The steel pontoons, each 5 feet by 7 feet by 5 feet, could be combined in any configuration. They were connected with heavy pins and steel angles, forming stable floating surfaces that could carry tanks, trucks, and cranes. The Seabees could unload them from cargo ships, bolt them together on the water, and in a matter of hours create floating causeways that extended from ship to shore. Each operation began the same way. Reconnaissance aircraft mapped the coastline. Naval engineers studied tide charts, coral ridges, and prevailing wind patterns. Once a suitable landing beach was identified, the Seabees rehearsed how to assemble the pontoons under fire. When the invasion began, they rode in behind the first assault waves, landing with bulldozers and welding torches still warm from the decks of their ships. A single pontoon unit could carry over 25 tons of weight, and when joined, their strength multiplied geometrically. The surfaces flexed with the waves rather than resisting them, an innovation that made them nearly indestructible in heavy surf. Crews learned to drive trucks straight from an LST's ramp onto the floating roadway, then onto the beach, delivering supplies that would have otherwise taken days to unload. The system extended beyond causeways. Engineers designed floating dry docks, barges, fuel lines, and mooring platforms using the same pontoon technology. This meant the U.S. Navy could repair ships, refuel destroyers, or build airstrips within days of capturing an island. By late 1944, entire harbors could be assembled at will, each one temporary yet powerful enough to sustain entire fleets. One of the most striking examples occurred during the Mariana Campaign. On the beaches of Saipan, Seabees constructed pontoon causeways so quickly that within 48 hours of the first landings, tanks and artillery were rolling ashore in organized convoys. Japanese observers on the cliffs radioed Tokyo in disbelief, describing metal roads on the sea that appeared overnight. They had never seen such a transformation. The Imperial Army had spent years fortifying their islands with concrete bunkers and anti-ship guns. Yet the Americans had brought an entirely new kind of strength, the power to adapt. Japanese doctrine had been built on the assumption of isolation. Each garrison was expected to fight to the death, cut off from reinforcements. Their supply lines were already strangled by U.S. submarines. The Americans, on the other hand, were fighting a connected war. Floating docks, repair bases, and mobile supply depots turned the Pacific into a single, fluid system of logistics. Every captured island became a stepping stone for the next, each one supported by an instant port that arrived with the fleet itself. Behind this logistical miracle stood minds like Rear Admiral Ben Moriel, the founder of the Seabees, and Commodore William Warfield, who led much of the Pacific construction. They believed that engineering, not just artillery, would decide the outcome. Their designs fused military necessity with industrial innovation. Every bolt, pin, and pontoon had to fit perfectly, whether in calm seas or under bombardment. As operations scaled up, the floating dock concept was refined. Engineers learned to link pontoons in staggered patterns to distribute stress. They developed flexible hinges to allow the floating causeways to rise and fall with waves. and anchor systems that kept them steady even under typhoon winds. These improvements came at a price: steel, manpower, and the relentless pace of production. American factories, untouched by war on home soil, met the demand with astonishing output. By 1945, over 1.5 million tons of pontoons and floating components had been shipped across the Pacific. To the Japanese military, these advances seemed almost supernatural. Their own forces relied on small, fixed ports that were easily destroyed. The concept of assembling a port at sea defied everything they had prepared for. Even when intelligence officers intercepted technical manuals or captured photographs, the idea seemed impossible to replicate. Japan lacked the industrial base, the shipping capacity, and most critically, the flexibility of thought to mirror it. As the war drew closer to Japan's home islands, this technological gap became a chasm. America could build a base anywhere. Japan could defend only what it already held. The floating dock was more than steel and bolts. It was a manifestation of strategic imagination, a physical answer to the tyranny of geography. And soon, that imagination would be tested in battle, on beaches where the sea itself would become both the battlefield and the foundation for victory. Every dock began not with blueprints but with men, mud-caked, sunburned, half-deaf from explosions and utterly relentless. They were the Seabees, 250,000 strong by the height of the war. Their faces didn't appear in war posters, but without them, the Pacific campaign would have stopped at the first coral reef. On the beaches of Leyte, Saipan, and Iwo Jima, they landed almost alongside the Marines. While riflemen advanced inland, the Seabees turned to the sea, unloading sections of pontoons, bolting them together under artillery fire. Waves crashed around them. Shells landed close enough to shower sparks off their helmets, and yet they worked, calm, methodical, as if construction itself were a weapon. Their gear was primitive by modern standards: acetylene torches, wrenches, sledgehammers. But their improvisation bordered on genius. If a section warped from blast pressure, they bent it back with a tank. If a pontoon leaked, they patched it with scrap steel. Their camps grew into miniature cities, workshops, generators, field hospitals, all assembled on open beaches. In film reels shot after the battles, you can still see them, bare-chested under the Pacific sun, sparks flying as they weld steel into shape. Each clang of hammer against metal was another heartbeat in America's logistical pulse. They weren't just building docks, they were building momentum. Commanders often said that wherever the Seabees went, the war advanced. They didn't wait for the front line to move, they created the front line. Their floating docks became symbols of a new kind of warfare, one powered by engineering courage as much as by combat heroism. At its core, the floating dock system was a masterpiece of simple physics. Each pontoon, made of welded steel plate, had airtight compartments that gave it buoyancy. Alone, one could float a truck. Linked, they could bear the weight of tanks, artillery, or entire warehouses. The secret was not in the material, but in the modular logic, a design that turned the Pacific into a giant assembly line. The components were shipped flat, nested inside each other to save space. Crews could unload hundreds from cargo holds in hours. They were then towed into position, bolted together, and anchored using steel piles or heavy chains. The result was a structure that moved with the sea rather than against it, a living extension of the ocean itself. Each section was designed with universal interchangeability. A pontoon from Guam could connect seamlessly with one from Okinawa or Leyte. This standardization allowed engineers to think like logisticians, not bricklayers. It turned the entire U.S. Navy construction effort into one coordinated system of floating architecture. And it wasn't just for unloading cargo. Some pontoons were modified into fueling stations, floating workshops, and crane platforms. Others became temporary airstrips, their metal decks strong enough for reconnaissance planes to land and refuel. When storms hit, the floating docks flexed, absorbing wave energy instead of collapsing. When the sea calmed, they stood solid as pavement. This system represented something deeper, the fusion of industrial design and military strategy. America's factories had learned to mass-produce not only ships and planes, but also infrastructure, portable, adaptable, and invincible. It was a triumph of imagination, a fleet of man-made islands, each built from a pattern so elegant that even the chaos of war couldn't break it. Before floating docks, every amphibious landing was a race against time. Supplies piled up on the beach faster than men could move them. Landing ships became bottlenecks, vulnerable to air raids and submarines. A single storm could halt operations for days. But the moment the pontoon systems arrived, the entire tempo of warfare changed. At Leyte Gulf in October 1944, the system was tested under fire. Within hours of the landings, floating causeways connected the ships offshore to the beaches. By nightfall, artillery and tanks were already rolling inland. The Japanese had expected weeks of disruption. Instead, the Americans were moving with clockwork precision. The tactical value was enormous. Floating docks allowed simultaneous unloading of multiple vessels, cutting logistical delays by more than half. They eliminated the need for deep-water ports, neutralizing one of Japan's greatest geographic advantages. Even in heavy surf, operations could continue. When storms tore through the Philippines, the causeways bent but didn't break. For commanders like Admiral Raymond Spruance and Vice Admiral Richmond Turner, this flexibility became a strategic weapon. They could plan assaults knowing that the fleet carried its own harbor. No longer constrained by geography, the U.S. Navy gained an almost supernatural freedom of movement. To the enemy, it felt as if the Americans could conjure ports out of thin air. On islands like Peleliu, Japanese officers radioed that the sea itself aids the invader. They weren't wrong. Every pontoon, every floating bridge was a silent instrument of victory, proof that the Pacific could no longer protect Japan. From human grit to industrial genius to battlefield mastery, the floating docks were rewriting the rules of war. And yet behind every triumph stood another perspective: the enemies. Those who watched in disbelief as the ocean itself turned against them. On the beaches of the Philippines and the volcanic ridges of Iwo Jima, Japanese lookouts recorded their observations in clipped, stunned sentences. Floating bridges, large ships connected by iron roadways, movement of vehicles across the sea. The reports made little sense to their superiors in Tokyo. The Imperial General Staff, trained on a doctrine of fixed defense, could not comprehend a war where the enemy built the battlefield itself. Japanese intelligence had long expected America to rely on seizing existing ports. Every stronghold, Rabaul, Truk, Palau, was fortified with that assumption. When those ports were bypassed entirely and new instant harbors began to appear offshore, it felt like sorcery. Officers watching through binoculars saw what looked like a mechanical tide creeping forward. Bridges, cranes, warehouses, all floating and assembling themselves. On Saipan, captured Japanese diaries revealed genuine awe. One soldier wrote, "They build the land on the sea. It rises and grows while we fire at it." Artillery batteries targeted the causeways, but the shells splashed harmlessly in water or struck the steel pontoons, denting but not sinking them. Even when sections were destroyed, replacements arrived within hours. For defenders conditioned to believe in unyielding fortresses, this adaptability was incomprehensible. The Imperial Navy lacked both the materials and the industrial backbone to attempt anything similar. Japanese shipyards were already crippled by bombings, and the shortage of steel made modular construction unthinkable. In their worldview, land and sea were separate domains. The Americans had erased that boundary. What they witnessed was not just an engineering feat, it was a psychological weapon. Every new harbor that appeared told Japan's soldiers that resistance was temporary, that America could rebuild faster than they could destroy. When the floating docks reached Iwo Jima, some defenders reportedly believed they were seeing an iron island rising to meet them, a final sign that the Pacific itself had turned American. Behind the miracle of floating harbors stood a few visionaries who understood that logistics, not just combat, would decide the Pacific. At the center of it was Admiral Chester W. Nimitz, Commander-in-Chief of the U.S. Pacific Fleet. Calm, analytical, and famously understated, Nimitz saw the Pacific not as an obstacle but as a chessboard, and the floating docks were his mobile pieces. From early 1943, Nimitz pushed for a logistics-first strategy. His operations officers, notably Rear Admiral Richmond K. Turner and Commodore William Warfield, coordinated with engineers from the Bureau of Yards and Docks to design modular harbor systems that could leapfrog across the ocean. Their aim was simple but revolutionary: never let the front outrun its supplies. This philosophy became the foundation of sea power through mobility. It wasn't about the biggest battleships or the fastest carriers, it was about endurance. Nimitz once remarked in a briefing, Our strength lies not in one port but in our ability to build one wherever we need it. That sentence defined the rest of the war. Under his guidance, the Seabees were given unparalleled autonomy. They could requisition ships, commandeer materials, and improvise on the spot. When Turner's amphibious task forces landed on new islands, they brought with them the tools to sustain themselves indefinitely. It was this foresight that allowed operations to move at a breathtaking pace, sometimes one invasion every few weeks. For Nimitz, the floating docks weren't just engineering solutions, they were manifestations of strategic philosophy. Japan's empire was static. His was fluid. Japan built walls. He built bridges. Every time a pontoon causeway touched the shore, it was as if his strategy had physically arrived, a living embodiment of motion, adaptability, and American industrial will. In hindsight, the War of Floating Docks tells a quiet truth about the Pacific Campaign, that the decisive weapon wasn't a bomb, a tank, or even a battleship. It was the ability to think differently. Japan had prepared for a war of attrition, where courage and fortifications would slow the enemy until exhaustion set in. America instead fought a war of innovation, where every obstacle became an opportunity to invent. The moral weight of this shift was profound. The floating dock was a symbol of human creativity applied to destruction, yet also to survival. It saved thousands of lives, both by speeding supply lines and by reducing the chaos of beach landings. Each steel section was a paradox, a machine of war, built with the discipline of peacetime engineering. There's also a deeper reflection here. The Seabees' philosophy, can do, represented the democratic spirit of improvisation. They weren't elite soldiers born for glory. They were citizens, workers, and craftsmen who turned their trades into tools of victory. In that sense, the floating docks embodied the same ideals that fueled the entire American war effort: cooperation, adaptability, and the belief that no challenge was unsolvable. Strategically, the docks shattered Japan's last hope of containment. The empire could no longer predict or prepare for where the next invasion would strike. The ocean, once their greatest defense, had been conquered, not by guns but by geometry and steel. The Pacific War was still raging, but its outcome had already begun to tilt irreversibly. The Japanese could fight the soldiers, but they couldn't fight the idea that America could build a new world wherever it chose. By now, the concept of the floating harbor had evolved from experiment to weapon. The next step would prove its ultimate test, when the Pacific turned into a storm of fire and steel, and the harbors would decide not just efficiency, but survival itself. Leyte Gulf, the Philippines, October 20th, 1944. The sky is thick with smoke and salt spray. Battleships boom from beyond the horizon, shaking the sea itself. The largest amphibious assault in the Pacific so far is underway. More than 700 ships crowd the Gulf. Transports, destroyers, carriers, and landing craft, each packed with men, fuel, and the tools of liberation. As dawn breaks, the beaches of Leyte are chaos. The first waves of infantry push inland under artillery fire. Japanese shells burst in the surf, throwing geysers of white foam into the air. For the Seabees, this is the moment everything has led to. The floating dock system, months of planning and thousands of tons of steel, must now prove its worth, or the entire invasion could grind to a halt. From the decks of cargo ships offshore, pontoons crash into the water one after another, splashing beside landing craft. Seabees leap in after them, wading waist-deep through surf, ropes over their shoulders, hammering bolts under fire. Each section clanks into place with a hollow metallic echo. Slowly, impossibly, the shape of a pier begins to form. The Japanese had expected the Americans to choke on the reefs. Their gunners had zeroed in on the shallows, betting that heavy waves and coral would trap landing ships before they could unload. But now something else is happening. Trucks are driving on the sea itself. By midday, the first pontoon causeway reaches from ship to beach like a steel serpent. LSTs, landing ship tank, line up in formation, lowering their ramps. Tanks roll forward, treads grinding against wet metal, moving smoothly across the floating road. Behind them come trucks, artillery, crates of ammunition, bulldozers. Within hours, a flow of supplies stretches unbroken from deep water to the sand. To the Japanese observers on nearby ridges, it seems as though the Americans have summoned a harbor out of the waves. Their gunners fire again and again, but the steel pontoons shrug off most of the hits. Damaged sections are replaced almost instantly. Seabees, covered in oil, sweat, and seawater, work without pause. A witness from the 7th Fleet described the scene. The engineers were standing on what looked like a road made of iron, the surf breaking beneath their feet, and still they kept building. The sea couldn't stop them. By nightfall, the first floating pier is operational. Landing ships unload in steady rhythm. Ammunition trucks head inland. Wounded men are evacuated back down the same causeway to hospital ships offshore. The entire cycle of war, attack, supply, recovery, is now contained within this man-made artery. Behind the front lines, Admiral Kincaid's 7th Fleet reports to Nimitz that the pontoon dock's functioning perfectly under fire. The message is brief, but the implications are vast. America's war machine has proven it can build a port anywhere. The Japanese counterattack is ferocious. Dive bombers scream down from the clouds. One pontoon pier is hit directly, sending fragments of steel and seawater skyward. Yet even as fires rage, Seabee divers swim beneath the wreckage, welding replacements in the dark. Within a day, the pier is back in operation. The resilience of the system astonishes even the Americans. The floating sections flex with the waves and absorb shock. When a typhoon lashes the coast a week later, entire causeways are dragged inland, but the pontoons remain intact. Crews simply reassemble them after the storm passes. The dock's endurance becomes symbolic. Reporters embedded with the fleet write home about the piers that refused to sink. One war correspondent describes it as the moment the Pacific itself became American territory. Behind the drama, logistics officers take note of the numbers. Over 400,000 tons of supplies landed within the first 2 weeks. Nearly 100 LSTs unloaded simultaneously. Construction time for fully operational harbors under 72 hours. No previous invasion in military history had achieved such efficiency. The lessons of Tarawa and Guadalcanal, where men starved on the beaches waiting for ships to unload, had been rewritten forever. The floating dock had turned the tide not just tactically but strategically. For Japan, the realization was devastating. Their islands, once safe behind reefs and shallow waters, were now completely exposed. Every coastline, no matter how remote, was a potential American port. At Leyte, the transformation was immediate and psychological. American soldiers who stepped onto the docks for the first time described it as surreal. The feeling of walking on a living thing, a bridge between two worlds. Behind them, the sea still raged. Beneath them, steel floated like magic. Ahead lay the jungle and the long road to Manila. In the command tent that night, a naval engineer looked out toward the lights flickering on the water, the reflection of welding torches and anchored ships. He said quietly to a reporter beside him, "We didn't just land today. We built the shore." And indeed they had. The floating docks had passed their first great test. But ahead lay even greater storms, battles that would push the system and the men who built it to the absolute limit. February 1945, Iwo Jima. The island rises from the ocean like a black wound, its volcanic sand swallowing men, tanks, and dreams alike. The Japanese have turned it into a fortress of tunnels and bunkers. Every inch is zeroed for artillery fire. When the first waves of Marines hit the beaches, the chaos is unimaginable. Ash, smoke, and fire mixing with the sea spray. And yet, even here amid the inferno, the Seabees are already at work. Floating pontoons clatter off the sides of cargo ships. Chains rattle. Small cranes swing them into the water where construction crews, soaked in volcanic grit, begin linking them one by one. While Marines crawl forward under gunfire, the Seabees, unarmed except for sidearms, build docks in the surf, turning the deadly shoreline into a functioning port. By the second day, the first pontoon causeway touches Iwo Jima's black sand. Heavy trucks roll ashore carrying ammunition and supplies. Each section of the floating dock creaks under the weight, but it holds firm. Waves crash against the steel edges, spray bursting high into the air like cannon smoke. From above, the view is surreal. A harbor blooming out of nothing beside a battlefield that still burns. Naval officers monitoring from offshore cannot believe the speed. On Tarawa, it took nearly 10 days to unload a fraction of the supplies. At Iwo Jima, thanks to the pontoon causeways, thousands of tons of fuel, shells, and food reach the front in less than half that time. The docks never sleep. Night and day, cranes swing, engines roar, torches spark. Japanese resistance is fierce. Their artillery finds the docks again and again, pounding them with shell fire. But every impact only slows, never stops the work. When sections sink, divers recover them. When storms rip loose an anchor chain, the Seabees reattach it under fire. One Navy report simply read, "Enemy fire ineffective against floating installations. Operations continue uninterrupted." The floating docks become part of the rhythm of invasion, ships in constant motion, beaches alive with supply lines, and the sea itself turned into a logistical highway. By March, the pattern is unstoppable. Iwo Jima falls and the docks are already being dismantled, loaded onto transports and prepared for the next great assault. Okinawa. April 30 Okinawa. It is the largest amphibious invasion of the Pacific War, dwarfing even Leyte. Over 2,200 ships and 500,000 men converge on the island known as the Gateway to Japan. The Japanese High Command knows this is the final stand. Kamikaze planes swarm the horizon. The sea burns, and yet amid the chaos the same miracle repeats. Within 48 hours of the landings, floating causeways and pontoon piers snake out from the beaches. The sea, once filled with wreckage and bodies, becomes a stage for industrial choreography. Trucks roll in endless lines. Tanks clank forward, carrying supplies from ships that never need to anchor near shore. When a kamikaze dive bomber crashes into one of the floating docks, killing half the crew, survivors rebuild it by dawn. They patch the pontoons, weld through the night, and by sunrise the structure is functional again. War correspondents call them ghost harbors, appearing, vanishing, reappearing with every battle. By now the Seabees operate with machine precision. They've learned every trick: how to use damaged pontoons as breakwaters, how to link sections in rough seas, how to anchor harbors deep enough to dock Liberty ships. They create not just causeways but entire floating bases, repair stations, fuel depots, and even hospital barges, all connected in modular chains stretching miles offshore. The Japanese defenders, watching from their final positions, are paralyzed by disbelief. Their own navy lies shattered at the bottom of the sea. Their airfields burn, and yet the Americans build, always build. A captured officer later told his interrogators, "We believed the sea would protect us, but the Americans made the sea their ally." The success at Okinawa confirms what every U.S. commander already knows. Logistics has become the decisive weapon of the war. Admiral Nimitz reports to Washington that mobile harbor operations now permit sustained fleet action without permanent bases. In simple terms, the Pacific Fleet no longer needs to pause. It can invade anywhere, anytime, endlessly. By May 1945, Okinawa's floating harbors are handling more than 750,000 tons of supplies per month, more than some permanent ports back home. Wrecked Japanese defenses crumble under the weight of unstoppable resupply. Every shell fired by a Marine, every bomb dropped by a Navy plane, arrives via those floating docks. The system has reached its zenith. What began as a desperate improvisation in 1943 has evolved into an industrial miracle of coordination and courage. And just as it reaches perfection, the war nears its end. Within months, Japan will surrender. But on the water and the reflections of those steel pontoons lies the true image of how victory was built, not just fought. When the last floating dock of Okinawa is dismantled in late 1945, many of the Seabees quietly pack up their tools and go home. No parades, no medals, but every harbor, every base, every beachhead they built has left an invisible mark on history. Because by then the world has understood the truth. The Pacific was not conquered by force alone. It was engineered into submission. And as Japan's empire collapses, its commanders study in silence the impossible structures that had doomed them. Harbors made of steel, waves, and will. The war is ending, but the story of these floating harbors isn't finished. Their impact will ripple through history, in strategy and technology, and in the very idea of how wars are won. By the summer of 1945, the Pacific theater had been reshaped. Islands once considered unassailable were now stepping stones toward the Japanese mainland. Leyte, Iwo Jima, and Okinawa had fallen not solely because of bullets or bombs, but because of the harbors that rose from the ocean itself. The numbers were staggering. At Okinawa alone, the U.S. Navy offloaded over 750,000 tons of supplies in a single month. Tanks, artillery, trucks, and fuel moved seamlessly from ships to shore via the floating causeways, allowing frontline troops to advance faster than Japanese forces could react. For every Japanese artillery position destroyed, multiple replacements arrived, and every defensive bunker fell under a relentless tide of resupplied Marines. Japanese commanders were forced into reactive strategies. Their intelligence reports emphasized astonishment at the Americans' ability to build land where none existed. Army General Ushijima's notes from Okinawa capture the sense of helplessness. The enemy does not wait for the land. They bring the land to them. This logistical supremacy reshaped the battlefield psychologically as well as physically. Soldiers who had endured the horrors of Guadalcanal and Tarawa now found the invasion forces striking faster, with fewer delays and better supply lines. Morale among Japanese defenders declined as they realized that their assumptions about isolation and delay were obsolete. The strategic consequences extended beyond the immediate islands. Floating docks allowed the U.S. Navy to project power farther and faster than ever before. Where previously an island could hold out for months simply because resupply was impossible, now even remote atolls could be assaulted, supplied, and reinforced almost immediately. The balance of operational planning shifted. Japan could no longer rely on geography as a shield. The war was increasingly one of industrial output, engineering ingenuity, and adaptability. From the American perspective, the docks demonstrated that logistics could be decisive. Commanders like Admiral Nimitz and Vice Admiral Turner recognized that the ability to build a port under fire was equivalent to gaining an entire extra army on the battlefield. This recognition influenced subsequent operations, including the planning for potential invasions of the Japanese home islands, where speed and supply would have been critical for minimizing casualties and maintaining offensive momentum. Moreover, the human impact was significant. The Seabees, often overshadowed by frontline combat footage, had literally rewritten the rules of amphibious warfare. Thousands of lives were saved because supplies and medical support reached the troops efficiently. The innovation minimized bottlenecks that had previously led to delayed reinforcements and shortages during island assaults. These docks were not just steel and engineering, they were instruments of survival, ensuring that victory was not only swift but sustainable. Even as the war ended with Japan's surrender in August 1945, the floating docks remained a tangible testament to industrial and logistical mastery. Many were dismantled and returned to storage, yet their influence persisted in after-action reports, tactical manuals, and the lessons learned by naval engineers. The war had demonstrated that technology and planning could be more decisive than brute force alone. In effect, the floating docks had altered the psychology of warfare. Japan's inability to replicate or counter them highlighted a broader shift. In modern conflict, mobility, adaptability, and innovation could trump entrenched defenses. A fortress could be breached not only by overwhelming firepower, but by the ability to reshape the battlefield itself. As American ships departed the liberated islands, leaving behind the remains of temporary docks and hastily constructed piers, historians would later note that the true victory of the Pacific Campaign lay in logistics. Combat had determined who held the islands, but the floating harbors had determined how quickly, efficiently, and decisively they were taken. The floating docks of the Pacific War did not vanish with Japan's surrender. Their impact resonated long after the guns fell silent, influencing military strategy, engineering practices, and global logistics for decades to come. Immediately after Okinawa, the U.S. Navy began cataloging lessons learned. Engineers studied every aspect of pontoon assembly, wave absorption, and modular integration. Reports detailed how minor adjustments to hinge placements and anchor chains had prevented structural failures under heavy surf. These innovations were documented meticulously, forming the blueprint for modern amphibious and expeditionary operations. Meanwhile, Japan's post-war analysis focused intensely on these floating harbors. Engineers and military strategists pored over captured manuals and photographs, attempting to understand how such a massive logistical feat had been achieved. For Japan, it was a bitter lesson. They had invested heavily in static fortifications, yet the Americans had rendered them obsolete with flexible mobile infrastructure. Scholars later noted that this realization influenced Japan's post-war engineering philosophy, particularly in civil construction and maritime logistics. The docks also inspired Cold War military thinking. Modular transportable harbors became part of U.S. contingency planning for potential conflicts in remote or hostile environments. By the 1950s, pontoon systems were standard equipment for amphibious exercises, and engineers were exploring more advanced materials, like aluminum and reinforced composites, to increase durability and ease of transport. The core principle remained unchanged. Control of logistics could dictate the tempo and outcome of a campaign. Beyond military applications, the innovation influenced civilian engineering. Temporary bridges, floating docks for commerce, and emergency harbor solutions drew directly from the Seabees' wartime experience. In disaster zones, engineers would later deploy floating systems to restore port access in hours instead of weeks, a legacy born in the Pacific Surf of 1944-45. On a human level, the success of these harbors highlighted a fundamental truth about warfare. Victory depends as much on ingenuity as on weapons. Japan's soldiers, who had once been confident that isolation and geography would secure their defense, witnessed firsthand the consequences of unmatched adaptability. America's ability to assemble land from the sea became an enduring symbol of operational flexibility, a concept that continues to inform modern military doctrine. By the war's end, the floating docks had saved thousands of lives, accelerated the timetable of the Pacific Campaign, and demonstrated that engineering excellence could function as a strategic weapon. From Leyte to Okinawa, they allowed the U.S. to sustain operations far beyond the reach of conventional ports, giving planners the freedom to strike where Japan least expected. The psychological effect on the enemy, combined with the tangible tactical advantage, exemplified how innovation could tip the balance of power decisively. Ultimately, the floating harbors left a dual legacy: immediate military triumph and long-term technological influence. They illustrated that the battlefield extended beyond rifles and artillery, that it included the skills, tools, and ideas capable of transforming the environment itself. For the Pacific War, they were not just a component of victory. They were a revolution in how wars could be waged and won. As the last pontoon sections were retired and the war receded into history, one truth remained clear: America's ability to construct harbors where none existed had permanently reshaped military strategy, leaving an indelible mark on both sides of the conflict. And from that mark, lessons would ripple through generations of engineers, soldiers, and planners, ensuring that the innovation born under fire would never be forgotten. The story of the floating docks is a quiet testament to ingenuity. They were steel and bolts, yes, but also courage, creativity, and relentless human effort. In the Pacific, victory was not only a matter of bullets or bombs, it was a matter of vision. The Americans imagined the impossible: a harbor on the open sea, and then they built it. These modular piers and pontoon causeways were more than tools. They were symbols of adaptability in the face of uncertainty. Where geography once protected the islands, it now facilitated America's advance. Where isolation once delayed campaigns, innovation accelerated them. The Seabees, ordinary men turned extraordinary builders, showed that perseverance and skill could reshape the battlefield as effectively as firepower. Japan's inability to replicate the docks revealed a fundamental truth about warfare: static defenses cannot withstand a foe who controls movement and logistics. The floating harbors were not just tactical marvels. They were psychological weapons, breaking the illusion that some places were untouchable. They proved that flexibility, planning, and industrial ingenuity could overcome entrenched obstacles, turning even the ocean into a strategic asset. Beyond the war, the legacy of these harbors endures. Modern military engineers, disaster relief planners, and logistical strategists continue to study and adapt the principles developed in those harbors: modularity, rapid assembly, resilience under stress. What was once a necessity of war became a blueprint for human problem-solving under extreme conditions. In the end, the floating docks remind us that wars are not won solely by might. They are won by thought, design, and the courage to act on imagination. A system of steel that transformed oceans into ports also transformed the way humanity understands possibility. Victory was built not only on the beaches of Leyte or Okinawa, but in the minds and hands of those who dared to turn water into land. And as the Pacific waves continue to roll over those islands, the echoes of hammers and welding torches linger, a quiet, enduring monument to innovation, resilience, and the power of human ingenuity.